Okay, logs. On this question, there's no little baby base number. So what is actually there if there's nothing present? There's really a 10. Okay, so if I really want to think about it, 10 is the base, and it's not written how it should be. What's the problem? Factor out like that. Factor, that's a B, right? That's a B transformation. So factor it out. Has to be factored out.
Oh my goodness.
Okay, so with logs, exponentials, you start the same way. 10 to the negative 1, 10 to the 0, 10 to the 1. Give yourself 3 points. What is a 10 to a negative 1? 1/10. How do you write the points when it's a log? Do you do exponent comma result or result comma exponent? Result comma exponent. It's backwards, so it's output comma input, right? Okay, so those are the 3 points. Now, this is a B and this is a C. So I'm going to go like this. X divided by negative 1, comma, plus 4, comma, Y. B, C. Know how to apply your transformations? You have to do it now with every type of graph. Okay. You probably won't have a calculator present in this. So what is negative 1/10 plus 4? Or 4 minus 1/10? 3 9/10. Negate, what's negative 1 plus 4? Negative 1 plus 4? 3. Negative 10 plus 4. Oops. Does anybody know what a log shape should look like? What about the asymptotes of it? Asymptotes are vertical. This one has transformed to the right 4. Okay, so this is a normal log. You should always have that, just picture in your head. What should a log look like? That's a log. So did it reflect and shift right? Yeah. Okay. This you should need to use your calculator for, actually. What is the same thing? Oh, I didn't do this right. I think I wanted an ln x there. Ln of x. Sorry. Okay, when you see ln of x, it's the exact same thing as what else? I know I made a mistake. Can you just like put an x there? Log E. So ln is the same as you using a base of E. Does anybody have that number just off the top of their head without their calculator? 2.7-ish? Okay, so e to the -1, e to the 0, e to the 1. This is on a graph, so you can just do it 1 decimal because it's on a graph. I'm not going to see your 3 decimal places on a graph, right? Okay, this is a logarithmic. So again, I write my coordinates, results, comma, exponent. If it's a log, it has to be the backwards order of your brain. And what kind of transformations do we deal with? This is a letter A, and this is a letter D. So what do you do with the A and the D? Okay, remember how a normal log looks? Know that it's reflected and up 1. But I didn't move the asymptote at all because the only way to move that asymptote is right and left. Get it? If this goes up or down, it's not moving anywhere. Okay, so just remember that secret base of 10, the secret base of E. Okay, exponential. Okay, you should always pick your base right away. Doesn't matter. Exponential log, you should always say, what's my base? Your base is 3. Your base is not -3. It's 3. Negative is an A, which is an afterthought. It's a transformation after. Okay, so 3 to the -1, 3 to the 0, 3 to the 1. If it is an exponential, you should write your coordinates, exponent, comma, results. Okay, now I go back to my transformations. There was an A, and then this would be a C. Okay, maybe you should think about what a exponential graph looks like. Exponentials always have a flat asymptote, and if it's a 3, if your multiplier is 3, you should be growing. So this would be what it should look like. And then we did a reflection. So we've reflected it that way and shifted it right. So can you visualize what that would look like now?
So the
Asymptote did not move.
change, or
If there's a C, or is there a D?
Okay.
Yeah, is that what you were going to say?
Yeah, but if it's log, it changes if it's a C.
C, yeah. Okay, and then the last one has a base of a half. So a half to the -1, a half to the 0, a half to the 1. Exponent, comma, results. Exponent, comma, results. And then this time, the only transformation I see is a D. So we're going to need to go down 1. I hope that they give you graphs that are already labeled. If they don't, make sure you're labeling. Okay, so that was it for the graphing part. Okay, I'm going to skip that one. We'll do a harder one later, so then we'll cover that. Okay, estimate using benchmarks. You do not have a calculator on this question. Okay, this is a base, and this is a result. We are trying to figure out the exponent. So give me some values you would know. 2 to the 2 is 4, 2 cubed is 8, 2 to the 4th is 16, then another 2 is 32, another 2 is 64, I'm going to stop, 40 is between there, so my exponent is between 5 and 6. And then you have to estimate to 1 decimal. So x is approximately equal to 5.34, something probably less than the halfway. 2, 3, 4, all acceptable. Okay, just to note, what if the question was different and it just said that? It just said that. How would your answer be different than this answer? You would just answer 5.3. So be careful. That's how they get you on the exam. You have to be careful. I said here it was equal to x, so then my answer was x equals that. Unless you define it and you say let x equal this, then you can state that in your answer.
If you say what?
If you were just given this, you could make the statement let x equal this,
Okay.
and then you could say x equals.
Okay.
But if you don't, it'd be like me saying, hey, what's 4 times 5, and then you answering x equals 20.
Okay.
Right? You're throwing in x when it's not there. Okay. Who can identify the strategy used to solve this? And actually, it's not with a calculator at all. You can't use it. Same base. So there is a 25 as a base here and a 1 over 125. What kind of matching number can we use with that? A base number that they would both belong to as a group. 5? Okay, so how would you rewrite 25? 5 squared. How would you rewrite 1 over 125? 5 to a negative 3. Okay, so even at this point, if you want, you can drop the 5s. They can be done. You can conclude this exponent equals this exponent. Okay, no calculator, right? Okay, I would say if you don't have your log rules mastered, you're going to run into a lot of difficulties. Okay, log rules need to be mastered. Okay, let's first of all talk about the square root. What's another way to write a square root exponentially instead? It's to a half. Okay, Ready? 1/2 log 5x. I move the exponent to the front. This was a timeser, so now it's going to be a add. These are separate timesers, so I'm going to subtract because it's on a bottom. And then this is also a subtract because it's on a bottom. Okay, can you work back or to group it back? Can you give me one big chunk there undoing the rules? Can you go back and forth with the rules? Can you tie it back together? Okay, evaluate. Let's jump to number 2. They're the same, but this one's harder. Okay, what I'm going to do is I'm going to identify this as a base. I'm going to identify that entire thing as an exponent. And I'm going to write equals a result. Remember all your positions? So right now it's in what kind of format? Exponential. A base to an exponent, that's exponential. So I'm going to change the format to be a log format. So log base, so 4, results equals exponent. So exponential form, I maneuvered to log form. Now, do they both start the same? No. Can I move this? What could you do with this 3? It can move over there. So now log 4 something, log 4 something, can we make the conclusion? This would have to be equal to 125 would be the answer. Okay, this one, log 464. So this is a base. This is the results. So what is your brain doing? 4 to something exponent would be 64. That's what your brain is doing, right? No calculator. Four times 4, so squared, is 16. What do you think? 16 times another 4? 3. Log 4, 2. So the base results, so the 4 to something would be 2. That's a 1/2. No calculator yet. What's 3 divided by 1/2? 6. Okay, last one of these, log 2 16. So your brain does this. 2 to something would be 16. That's what your brain is doing there. Base of 2, it ended up as 16, so the exponent is 4. You should know your 2 bases. You probably get those a lot on your exam without the calculator. So 2 to the 4th is 16. So now I bring that down. So the question is, what's log 16 for? So the base to some exponent equals result 4. So that should be final answer. Aha. Okay. This question. Okay, what we have to do is we have to think of ways to produce a 10. Your log rules only can be used if you have things that are multiplied, divided, or exponentials. And exponentials include radicals, right? So how do you get me a 5 somehow using a 4, or sorry, how do you get me a 10 using a 4, a 5, or an 8? And you're only allowed to use multiply, divide, radicals, and exponents. What's that? Square root of 4, which is 2, times 5. Is 10, yeah. Square root of 4, you said? So that's just the same thing as a 10 right there. Now, rules. Everyone understands that this is equivalent, 4 to a 1/2. So how do you separate? I'm going to change this question. I'm going to change it. Because this is one that tricked people in an exam. They just made it something random. So how would you express this at the end? A half m plus an n. Okay, what do you want to do to make a 16? 4, a 5, or an 8? 4 squared. 4 squared is a way to do a 16. So what would that look like with the rules? You would just, yeah, you would just do 2 times 3.419. Okay, 1.6, how do you, what did you do? No, what did you do? 4 squared. 5 times 2, but there's no 2, but you maybe want to do that. That gets you there. That's a very complicated way of getting there. There's something simpler.
8 divided by 5.
8 divided by 5. That also works. Do your way. That works. Okay, then talk about the rule separation. The division separates with subtraction. Okay, just really fundamentally understanding the rules. Exponents become coefficients, multiplies become adds, divisions become subtracts. Okay, solving harder equations. Here, this is where it got intense. What's your first instinct with all this?
Glue it back together.
Glue it. Glue it. It was separated with add. You all right, hairball?
Right over there.
Not a hairball there, what?
Okay, so do you see what I did? The two separate adds glued together with multiplication. Then, this is in a log format. So what do you think I should do? Switch it to exponential. So base 4 to exponent 2 equals result. Okay? So 16 equals 10x minus x squared. Nico? Equals 0.
Nice, Nico.
I'm gonna, I don't like the negative over there. Are these answers allowed? Do they work? What do you know? This results cannot be what? Can't be, you can't have anything negative. So if you were to plug in an 8, are you good? Yep. If you plugged in a 2, that's fine as well. If I had a 15 in here,
Good.
would not work. A 15 would not work because then it's negative. Okay, now we're going to go the opposite. This is a exponential equation. So what do you think I should do if it's exponential? Do something with logs. So I'm going to log. Yeah, they kind of always. So I log both sides. Okay, here comes the big part. You need to make sure the rules here. You have to have the rules down pat. There's a multiply. So log 5 plus do you see my separate adds? I also moved a coefficient or exponent to a coefficient. Okay, I had this in brackets. Do you understand on this problem, the whole thing is using a base of 10, okay? So when I say log 5, 5 isn't the base is actually a 10, but I'm not writing it. Okay, some next steps. Distribute. Okay, what do we do here now? Where would you go? Separate. So my goal would be anything that has an X is on one side, anything without an X is on the other. That's kind of the understanding. So really I only did one thing. It looks complicated, but I only did one thing. Now I would factor out GCF. Okay, this would be a for sure calculator question. Make sure you understand your calculator. You put brackets. Let's
Yeah, you do it in your head.
yeah, can you do that in your head?
I think that's
You do the first one. What?
Can you give me that?
So what I got. You can check your answer when you're done too, right? You can go back and kind of plug that in up there and see if it all is the same. Okay, 3 decimals. Okay, I want to summarize.
4.651.
If I summarize here, logs glue together, turn to exponential. Exponential, log, separate. You see how you're just doing opposite stuff? Glue, exponential, log, separate. Okay, got it? Opposite things. Okay, Jackson, you're not using a backwards calculator still, right?
No, I've switched.
Okay. Probably a good thing for the exam. Okay, let's do one word problem. You would have a very high chance of getting a population or a money question or the earthquake question. Those are the 3. I'm sure that there's usually one of them on there. Good chance. Okay. So here's the formula. The population equals the initial population times that. So that's the ending population. That's the starting population. How much time should I put at the top? From 2000 to 2014, 14 years.
Would that be crazy? That'd be like a ideal life.
Okay, so right now, this is, would you consider this an exponential equation, right? So if it's exponential, then I should log both. Is there a different trick on this one though? I'm going to natural log both sides because I saw an E. Is it wrong if you log both sides? No. You will get there as well.
Dude, how did you get
Okay, so once I do that, the rules allow me to move the exponent down. That's the whole point. That's the only way you can solve an exponential is when you move it down. And here's why we picked ln, because the ln of e is 1. If the base is e, the result is e, that's a 1. So if you didn't use ln and you use log, you have to keep log e in there. And then to get r alone, I just divide by 14. So this is exactly what I'm typing in there. Okay, then I'm keeping it on my calculator. Do not touch your calculator. What's the population in 2020? So what is the population? We started at 13,000. And in 2020, that means there'd be 20 years from that population. Okay, do we remember how to specifically type it? It's all about the type. Okay, what am I going to do? I'm going to times by 20. Times by 20 equals. Then I'm going to do e to that number, e to that number, e to that equals. Then I'm going to times by the 13,000. And this is a population, so you can do this one as a whole number. So that one you would be expected to do a whole number. Hopefully they also give you a little bit more instructions, like estimate to the nearest person or whatever.
That was the next day of work.